G'day YouTube. Warbles on a lot here. Those of you familiar with my channel are aware that I'm a bit of a hillbilly sort of thing, kinda. And to be a hillbilly in good standing, it isn't actually enough to merely live on top of a hill. You have to be able to live by the principles of save it, use it up, make it do, don't throw it away, and if you can't afford to buy it, make it yourself. And even if it is broke, fix it. And one of the rules of the game is that when a hillbilly finds something that's been produced in a factory, manufactured at great expense, to the design of somebody who went to university to learn, to design whatever the hell it is that somebody else went to university to learn how to get the finance to pay for somebody else who went to university to learn how to manufacture it and produce it, so that somebody else who went to university to learn how to distribute it can successfully sell sufficient copies to pay for the entire process. And when it goes wrong, the role of the hillbilly is to figure out what's gone wrong and then to use whatever is available, which will not only repair it, thereby correcting whatever mistake was made by the series of university educated brilliant individuals who caused it to fail in the first place, but you got to fix their underlying design flaw which caused it to fail in the first place. And sometimes they're pretty good at it, actually. So sometimes you'll find that at the high end of the market, a good team of designers and production engineers will put something together that's elegant and functional and it lasts, but they've pushed their materials to the limits, and after, let's say, 30 years, the item that's been pushed the hardest for the sake of elegance, that's where it fails. I've got a problem like that on my workbench right at the moment. Those of you who are familiar with sewing machines have probably heard of a thing called an overlocker. An overlocker is a really complicated sort of a high-end, top-of-the-line sewing machine that's used for doing the specialist sort of sewing. Anyway, this comes off an Elna overlocker. And like a lot of good ergonomical engineers, they've combined two functions into the one item. On the one hand, they need a lever which can rotate a shaft against a spring pressure in order to lift the sewing foot up off the piece of material that's being worked on. So this functions as that. The other thing is that the only time you really ever want to cut the threads is when the foot is up off the material. So therefore, as you can see, there is a little knife blade here in a recess. So this is the sort of cutting off hook and foot lifting lever. And over the years, the plastic has decided to fail spectacularly. Now, we can see that the Swedish engineers weren't silly enough to expect a metal shaft to operate against plastic directly, so therefore they've got a little spring steel insert. And over the years, under repeated use, it's failed, and as you can see, it's also cracked along there. So the challenge facing this little hillbilly after saying good day to the swamp wallaby My theory is to repair the plastic first and then reinsert the little load-bearing spring steel bush after I've reinforced the plastic so that it won't break again no matter how strong the loads are. So I propose using Selly's 2-part plastic primer and glue for specific uses. And in preparation for this, I've already used methylated spirits to clean the plastic because being inside a sewing machine, it was all liberally coated with light sewing machine oil. I can't actually see any functional way of getting into that crack. So I'm going to glue the main piece back on, and then I'll use the additional strengthening to make up for leaving that crack where it is. It won't ever get stressed again. I find the trick with this is to make sure that it is flowing before applying this solvent pen to clean the edges which are to be glued. Yeah, this stuff's just gone chalky with age and fatigued under the stress. Okay, now we'll put a little tiny bit of this on. Let it soak into that crack there. And while it's still wet, you push it in there pretty quick and it clamps pretty much instantly. Okay. Now that is where a lot of people would leave this. However, all that means is you're depending on a secondary chemical bond to try and hold it together right at the exact place where the stress riser caused it to fracture last time, and I think that's a bit of a silly idea. So here's my plan. We take some nylon kite string, probably about 150, 200 pound breaking strain. So here's the plan. Free end sticks out on one side with a loop going over the other side. Now we take this and we wrap it moderately tightly. Whoops. Let's try on the other side. It'll work better. Okay, so we wrap this moderately tightly. Taking care to entrap the thread. Thoroughly wrapping the piece before cutting it off with the attached cutter. And then putting the last wrap through that loop before using a pair of pliers to pull that tight. And then bury the knot underneath the winding and simply cutting off the loose ends. If they'll come off. Like so. Very neat. And that'll definitely stop that broken segment, quadrant I guess, from being able to escape again. However, it's not finished. Now we do exactly the same trick again, this time at 90 degrees to the first wrapping. Once again, entrapping the loose end and the loop, while I'm not sure whether that helps or hinders. Trying to put a light on it. Anyway, I've pretty much reinforced that crack as much as I can manage. So now we put the final end of the wrap through the loop and simply pull it through as well. Once again, cutting off the ends. Right. So now the idea is to turn these fibres into a fibre reinforced epoxy composite shell around the old part. Okay, so we take our 5-minute araldite. We're not going to want too much. Damn. Oh, you mongrel. Well, that's way too much, but I can always find use for hot, wet araldite. All right. Now, the couple of things are I'm not allowed to get this araldite in the thread cutter, and I'm not allowed to get it inside the axle hole. But that should work out all right, I think. Okay. Okay. That's looking pretty good. Yep. Yep, I like that. Smooth that off there and smooth that off there. Smooth that off there. Put all the extra stuff along there. And make sure we got full coverage over the top of the crack. And now it's starting to warm up, so it's starting to go off. Nothing in the hole, nothing on the cutter. Okay, back shortly. Okay, so there you have it. It's effectively a nylon epoxy composite repair, a lot like what people used to call fiberglass, and these days they call it carbon fiber composites. Right, so now all I have to do is get this to fit back inside it with its two channels lined up with the two plastic ribs, like so, and then push it in all the way. Like that. And now I think I've pretty much fixed it, because this has been repaired a machine which is 30 years old, 35 years old, hasn't been in production for 25 years or so. There are no spare parts for, but it still works. This machine is now still a goer. And my little old 82-year-old mother will be greatly relieved. Warbles on a lot to YouTube. Ciao.